Welcome to the class, my dear students. Now we are entering into the non-homogeneous differential equations. So how to solve a non-homogeneous differential equation and what is the general solution? How do you write? In the previous lecture, I have explained that the general solution is given by the complementary function plus the particular integral. Now our job is to find the particular integral of this non-homogeneous equations. So to find the particular integral, we will now find out the method to solve the general solution to find out the particular integral. So now what is the equation? The standard form is f of d into y is equal to now x. X is of course not equal to 0, is non-homogeneous. Now yp, the particular integral, is given by 1 over f of d times of x. So that is your particular integral. Now the general method of finding out the particular integral is, this now. How to find out the particular integral is 1 over d minus a of x is given by e raised to ax times of integral of e power minus ax into the function x dx. So this is what the general method to find out the particular integral is equal to 1 by d minus a times of x, that is given by this one. But we generally follow, there are some shortcut techniques are there because it is a tedious process when you have such type of a method of solving the function sometimes. So then we use the shortcut methods to find out the particular integral. Now I'm talking about there are some forms to find out the particular integral. What is that? Let us see. To find out the particular integral, you have now, there are how many forms? I'll explain you. There is 1, 2, 3 and 4. There are 4 forms to find out the particular integral. So now when the function on the right hand side function x, whatever you get here on the right hand side of the function x, that particular function x now I'm talking about, okay, that x is suppose equal to e raised to ax, then this is called as form 1. This is form 1 when the right hand side equation is e raised to ax. When the right hand side equation is sine ax or cosine ax suppose, then this is called as form 2. When the function x is a polynomial in x suppose, then this is called as form 3. And if the function x is the e power ax times of some function v into v, where v is a function of x, and that is called as the form 4. So these are the 4 forms we are dealing with to find out the particular integral. Now I am dealing with form 1 now. So in this form 1, I am just writing down the explanation about, in the place of d, you are replacing a. Okay. So now in this, when you replace d by a, then whatever your yp is given by 1 over f of d times of e raised to ax. Now that will be 1 over f of a times of, when d is replaced by a, the power of e power ax is 1 by f of a times of e power ax suppose, or else. Now if this happen to be 0, if f of a happen to be 0, let us say, then we multiply by x and find f dash of a into e raised to ax. When this happens, now this is when, if f of a is not equal to 0. If f of a is equal to 0 and f dash of a should not be equal to 0. If at all this also happen to be 0, then multiply once again, that is x square times of e power ax x square times of e power ax times of f double dash of a, where when this happens, if f of a, f dash of a also equal to 0 and f double dash of a happen to be not equal to 0. So try to understand here, whenever you have f of a not equal to 0, then directly substitution. If that happen to be 0, then multiply by x and differentiate. If that also happen to be 0, then multiply by x and differentiate double times. So that gives you your particular integral. And then when you have x is equal to sine or cosine ax, suppose in this situation you are going to replace d square by minus a square, and then you will be doing the solving the problem. While doing the problems, I'll explain you how to solve this. In this, suppose if something happened to be 0 in the denominator, then there is a special cases formulas are there. Now that special case, now I am explaining you. The special case is 1 over f of d, means d square we write. Okay, it is a function of d square we write, of sine ax or cosine ax suppose. Then what we write, it is 1 over f of minus a square times of sine ax or cosine ax, whatever. Okay. So now again, this happened to be 0, f of minus a square to be 0 suppose. Then we use the special cases. What is that? This is the special case. Okay. Now what is that special case? In that we write 1 over d square minus a square times of sine ax is there suppose. What is the integral of sine? We know, minus cosine. So this 1 over d also is nothing but integration. So it is minus cosine ax multiplied by 1 over d square minus a square is equal to minus cos ax into x by 2a. So this is what we do. And 1 over d square minus a square times of, suppose you have cosine ax, then we write it as, for integral of cosine is positive sign, right? So it is sine ax multiplied by x over 2a, x by 2a sine ax, or minus x by 2a cosine ax. So this is what we are writing down. And now what is the next one? It is form 3, that is x is a polynomial in x suppose. Then what do you mean? How to solve this? By using the problem, I'll tell you, and even this I'll explain in the when we are doing the problems. Now let us come to form 1. To today's lecture I am going to do only the form 1 problems. Let us now have this type of an equation. So first one is, solve the equation d square y by dx square plus 3 minus 3 dy by dx, let us say, minus 3 dy by dx plus 2y is equal to e raised to 3x. So we have to generally find out the complementary function, all that. So what is d square minus 3d plus 2y is equal to e raised to 3x is your operator form. Then auxiliary equation is m square minus 3m plus 2 is equal to 0. Now what are the roots of this equation? That is 2 comma 1. Therefore, what is the complementary function? c1 e raised to 2x plus c2 e raised to 1x, which is x. So we got now yc, right? Now let us find out what is yp. Yp is given by 1 by f of d. What is f of d? D square minus 3d plus 2 times of e raised to 3x. Now what we are going to do? We are going to replace this value in the place of d. Okay? This is what we are going to do. So d is replaced by 3. So that gives you 1 over 3 square minus 3 times of 3 plus 2 times of e raised to 3x. So that value is what? 1 over 2 times of e raised to 3x. So that's why this is what your yp. So now what is the general solution therefore? The general solution is y is equal to yc plus yp. Y is equal to, the general solution is given by y is equal to yc plus yp. So what is the general solution now? Y is equal to yc, c1 e power 2x plus c2 e power x. Now yp, half of e raised to 3x. So this is what the general solution when complementary function and the particular integral are given. I hope you could understand this. Now let us solve another problem. So let us take this problem now. D square plus 2d plus 1 y is equal to e raised to minus x. So it is given that it is e power minus x. So definitely it is form 1. In the exam, it will not be given whether it is form 1 or form 2 or form 3. So you have to identify by saying the right hand side of the equation. Now the auxiliary equation is m square plus 2m plus 1 is equal to 0. So the roots are m is equal to minus 1 comma minus 1. Now what is the complementary function? It is c1 plus c2x to the power of into e power minus mx. Mx means your one value is what? Minus 1. So it is minus 1x. So all e power minus x. E power minus x. So this is your yc. Now what is yp? Let us see now. It is 1 over d square plus 2d plus 1 of e power minus x. Now d must be replaced by what? Minus 1. Okay. When d is replaced by minus 1, what is d square plus 2d plus 1 happen to be 0. Minus 1 plus 1 1 plus 1 2 minus 2 0. So this is what I said in the beginning of the cases. These are the special cases now, that d square plus 2d f dash of a is equal to 0. Now if you have f of f of a is equal to 0. So now what we write here, just find out, multiply by x divided by d square derivative 2d, 2d derivative 2 e raised to minus x. E raised to minus x. Now again if you replace d by minus 2, d by minus 1, then what happens? Your 2d plus 2 again becomes a 0. So again your value, that is what f dash of a is also happen to be 0. Therefore now 2d plus 2 is 0, no, so f dash of a is also equal to 0. So you multiply by once again x over derivative, derivative is 2. So this is what the particular integral. So you got the yc, you got yp. Therefore the general solution is yc is equal to c1 plus c2x times of e raised to minus x plus x square e raised to minus x over 2. So this is what the general solution. I hope you could understand. I have done one problem where you substitute, you won't get 0 or something. When you substitute, if you are getting 0, then what to do I have done in this problem. I hope you understood the lecture nicely, how to solve the non-homogeneous differential equation and how to get the particular integral we are dealing with now. I hope it is clear, my dear students.